Okay, good morning, everyone. As usual, how did the homework go? You guys have any questions? Number 71. Okay, we look at that. So what is number 71 about? So we have the following function in number 71. We have the function f of x equal sine x on the interval minus pi over 4 and 3 pi over 4. And the question is, find the area of the region bounded by the graph of f and the x-axis on the given interval. All right, so first let's see what the question means. Find the area of the region. I cannot find the area of anything unless I know the graph. So we have to know how this looks like. That's the function sine x, and between minus pi over 4 and 3 pi over 4. So let us remember how the sine goes. Start from here. It goes up, down, and then it goes back up like that, and then it does the same here. Okay, that's the sine. And let us remember that this is the pi. This is right here, 3 pi over 2. And this is pi over 2 and minus pi over 2. Now I want the area, I want the region between minus pi over 4 and 3 pi over 4. So this should be minus pi over 4 right here. And if this is pi over 2, 3 pi over 4 is here. Okay. So that's right there. Okay. So this here is minus pi over 4. Right here is 3 pi over 4. So that's the picture we're looking at. Okay, so I'm not interested in this, so I can take the pencil and basically my eraser and erase this region because I'm not interested in that region, and I'm not interested in this one. So I'm just gonna get rid of it because I'm not interested in it. So the region we're actually interested in is this. This piece goes up, down, up to here. That's my region. And I need this area. This is 3 pi over 4, and this is the area they want. Okay, so now that's my question. That's the graph of sine x. That's sine x. And I'm interested in the area that is shaded. That's my shaded area. All right, so now how are we going to find this? Who have any idea? I'm going to find this area. Okay, back to you now.
You use the fundamental theorem of calculus?
How? Explain.
You take the you take negative cosine x, then you plug in 3 pi over 4 to that, and then subtract.
Yeah, just jumping. Before you do that, the fundamental theorem of calculus is a tool to compute what? It's a tool to compute
definite integral.
Yes, now we're better. It's a definite integral. Fundamental theorem is not a definition. Fundamental theorem is what? What did I say it is, if you guys remember? Do you remember how did I say it is? It's a tool to evaluate definite integral. All right, now what's the definite integral? I'm backing you backward. I want definite integral. What does the definite integral represent? Graphically.
The area above the x-axis minus the area below the x-axis.
Very good. That's what it represents. And in terms of Riemann sum, let us remember that it's nothing, it's those sums. That's what the definite integral is. Those sums, those sums. I know it's hard to understand it, but that's what they are when n becomes large. That's what the definite integral. The fundamental theorem is a tool to evaluate the sum. It's not the definition. It's not the definition. That's the definition. And that's the one we will be using in calculus 2. That's the one they use in physics. That's the one in use in the sciences. The definite integral is the fundamental is a tool. So that's really the definition. What was our interpretation? Let us remember before we do even this problem. So I'm going to put here on purpose. That's not the answer because suppose I evaluate this integral, this definite integral. Okay, this is going to give me what in terms of the picture? What is going to give me in terms of the picture? Not answers. I don't want answers yet. In terms of the picture, what is it going to give me? What one of your classmates said. If I call this R1 and I call this R2. Okay, so this definite integral is going to give me first question, tell me true or false. Is it going to give me R1 plus R2? I meant the area of R1 plus the area of R2.
No.
No, that's not going to give me this area. It will not give me the sum of the area. What is going to give me? Minus the area of the region below plus the area of the region above. That's what the definite integral graphically is going to give me. Is this the question? The question is not that. The question is, what's the area of this region? What's the area? It means basically the question is, what the definite integral is minus this area plus the area. What the question in the book is, they want area of R1 plus the area of R2. That's what the question is. The definite integral will not give me that because the definite integral is going to give me minus this plus that. Are you with me so far? Are you getting with me? Or do you lost me?
So do you take the integral from 0 to 3 pi over 4 and then the integral from 0 to negative pi over 4 and then add them together?
Or from minus pi over 4, let us be to 0, and then I take negative of it.
Oh yeah, that's why I said 0
I know, you're right. Or I take that, I take minus it. Okay, exactly. So what we're going to do is we have to split. So first, we're going to compute the area of R1. R2, because that's the easiest one. R2 here, my function is positive. So the area of R2 is the integral from 0 to 3 pi over 4 of sine x dx. Why it is the definite integral? Because the definite integral is the definition of it. The definition of it is the sum of this Riemann sum. And graphically, those Riemann sum will give me the area. Okay, so it's the definite integral because that's what the definition of the definite integral is. Now, I use the fundamental theorem to evaluate. That's not the definition of the fundamental theorem. It's how to evaluate this. So we're going to evaluate it, which is going to give me the minus cosine between 0 and 3 pi over 4. Okay, it's going to be equal to minus the value at the upper minus the value at the lower, which would give me equal to cosine 3 pi over 4 is minus the square root of 2 over 2 minus 1. So this would give me the square root of 2 over 2 plus 1. That's the area of R2. Now, what's the area of R1? Okay, now your classmate did it absolutely correctly, but I'm gonna write something and I want you to fix it. I want you to fix it, be very careful. Suppose I take the area from minus pi over 4 to 0 of sine x dx. What does this integral give me in terms of the picture? If I take the integral from minus pi over 4 to 0, right here, my function is negative. What does the integral represent? Back to you. So my question here, the integral from minus pi over 4 to 0 of sine x dx. What does this represent graphically? Quickly, you should know. If I take the integral from here to here of this function, I always draw my rectangle to remind you that this is the sum of the area of the not the area. This is going to give me what? True or false? What I wrote, true or false? Are you guys with me? I want this. Is this true or false? What's the area of our
false?
What?
Won't that be false?
Absolutely.
Because wouldn't it be
Corrected.
negative area of R1?
Absolutely. That's the negative of the area. Okay, so the integral is negative of the area. So let's write this down now. The integral from 0 to pi, I meant from minus pi over 4 to 0, the integral of sine x dx is minus the area of R1. Means that the area of R1 is minus this integral. And what's that? Because f of x, what's that? Because f of x is negative on that integral. Okay, so the area of R1 is going to be minus that. So now we compute the area of R1. It's minus the cosine x between minus pi over 4 and pi over 4. And it's going to be equal to, this minus actually could be factored out. And this will end up with cosine x between minus pi over 4 and 0. And this will give me cosine of 0 minus the cosine of minus pi over 4. Cosine of 0 is 1. Cosine of minus pi over 4 is the square root of 2 over 2. This will give me the square root of 2 over 2. That's the area of R1. The area of R1 is minus the integral. So now the total area is just area of R1 plus area of R2. So the total area is going to be square root of 2 plus 1 plus 1 minus the square root of 2 over 2, which is going to be equal to 2. And that's the total area. Okay, so be very, very careful. It's a good problem because, again, it reminds us, at least graphically, what the definite integral represents. Please ask question because we're moving to the last section in the course for us. Okay. So I repeat the main idea. The definite integral from minus pi over 4 to 3 pi over 4 is not the sum of the area. It's minus this area plus that area. That's really what the definite integral is. So if I compute this definite integral, I'm definitely not going to get the area of the shaded region. So the only way to get the area, I have to split my domain. I have to split it between where the function is positive and where it is negative. When it is positive, the integral is the area. When it is positive, the integral is the area. When it is negative, the integral is minus the area. So if I want to compute the area, I just compute the integral and then I multiply it by a minus. End of the problem. Okay. Another question. Okay, thanks for the question. That's a good one. Okay. All right. So today so as we repeat what the fundamental term of calculus, always I repeat that it's the tool to compute the definite integral. It's not the definition of it. And to evaluate the definite integral, we need to find the antiderivative. That's really what we need to find. So it's really boiling down to finding antiderivative. So the question is now becoming how to find antiderivative or how to find indefinite integral. And that's will be what we're going to be talking about today and what you guys will be talking about in 164 for quite a while. Now, as I said last time, we know the antiderivative of very simple function, not a lot, and the cosine, the sine, the ex. And then last time, when the minute I forgot which problem I gave, something like 1 plus 5x dx. And we discussed that this one I have issues because this is not going to be the log of that. And the reason it's not the log was the chain rule. Because if I differentiate 1 plus 5x, I get 1 over 1 plus 5x times 5. So already this type of integral becomes problematic. And the question today is really we're going to deal with that, how to evaluate those type of integrals. So section 5.5. Integration by substitution. Okay. So I go back to ask the simple question. Suppose I ask you what's the antiderivative of cosine x. Okay, that's one we know. Antiderivative of cosine is the sine. Okay. Suppose I take the antiderivative of, let us say, cosine for x dx. Cosine for x dx. And my question to you is this equal to sine for x? True or false? Quickly.
False.
False. Absolutely false. Because when I differentiate that, I'm going to get the cosine of 4x times, that's a chain rule. I have an inside. Times the derivative of the inside, which is 4. Okay, so it's false. However, if I take the following, antiderivative of cosine 4x times 4 dx, is this equal to the sine of 4x? I mean, I'm reversing it. I'm reversing the chain rule. Is this true or false?
True.
This is true. This is true because what's the derivative of sine 4x is cosine 4x times 4. So this is true by the chain rule, but this is definitely false also by the chain rule. But let us a little bit look at this integrand here. What do you see inside the integrand? Let us notice something. That this integrand, this has the following form. Has a very specific form. If we look very carefully, it's like f of g times g prime of x dx. Okay, so it means we have an inside function, which is 4, times the derivative of the inside. So this has the form like f of g times g prime, where my f is what? Where is my f? And where is my g? Quickly. What is my f here? I'm reading. I don't say anything on the chat. You guys help me out. We have to learn a lot today. What is this integral has the form? What is the G prime in this picture, you think? And what is the F in this picture? In here. Okay, if you can't answer, it means you don't understand my question. G is the inside. So this has G is the inside, it's the 4x. And the outside is the cosine function. Okay, so this integrand has the form f of g times g prime, where g prime is just the derivative of 4x. What I have here is actually the derivative of 4x. And my outside is the cosine x. So the question now is how to evaluate those type of integral. The question is how to evaluate, in a way, integral where the integrand has an inside and the derivative of the inside is part of the integrand. So how to evaluate those type of integral? So integral where I have an inside function and the derivative of the inside is part of the integrand. So this type of function, I have an inside and the derivative of it is part of what I need to integrate. And the question is how to evaluate those type of integral. So we're going to use a technique to do that, and it's called the U substitution. So we're going to use a technique that we're going to learn, and it's going to be called U substitution, and you will see why the word U substitution will come from. All right. So at first I will explain, it's going to at the beginning, so may be a little bit hard because I'm going to explain where the idea comes from. And then we'll do a lot of practice problems, which will become a little bit, will become much easier. But first, the idea, how to do that, where this U substitution coming from. All right. The idea is that, so this is the integral I'm after. I keep them on this page to keep them in front of me. That's the integral that I am after. And here's the idea. Let us say that I know the antiderivative of this f. So suppose f is the antiderivative of little f. It means that f prime is f. Or it means that the indefinite integral of f of f. That's what's antiderivative. I'm going to here skip a line and I'm going to write here. So suppose I know the antiderivative of this little f, and I take this integrand here times g prime dx. So I suppose I have this type of integral, and I know the antiderivative of f. So this little f is f prime of something. Okay, so I have this type of integral, and I know that this is the antiderivative. Then this is integral going to be equal to the chain rule. I'm going to use the chain rule. How I'm going to use the chain rule? Chain rule tells me that if I have this function, f prime at g times g prime, that's the derivative of big F composed with g of x. Or, okay, because that's, remember what the chain rule here. That's the chain rule. Because let us see what the chain rule tells me. So let me rewrite it here. The chain rule tells me if I have f of g, the derivative is the derivative of the outside evaluated at the inside times the derivative of the inside. That's what the chain rule is telling me. Now, which is that? This exactly this term. So that's nothing more than the antiderivative of f composed with g. So this is the integral of f of g of x prime dx. Plus the integral of the derivative is the function itself. So this is f of g of x plus c. I am not worried about it. So this tells me that this integral, if I have an integral of this very specific format, an inside, and the derivative of the inside is part of the integral, so this is equal to, if I know the antiderivative of f, of little f, is nothing more than the antiderivative of f evaluated as g of x. Okay, so that's what this is telling me. Now, so the question is, to find this definite integral, this indefinite integral, I need the antiderivative of that. If I know it, I just plug in g of x inside. The question is, okay, why don't I isolate this problem? And I evaluate, and I'm gonna now use another variable, the antiderivative of f. Right now, I am focusing on the antiderivative. So if I compute this, I get f of u. And so I, instead of dealing with this mess here, I said, you know, the only thing I need is the antiderivative of that. So I take it by a problem, and I don't want to confuse the variable, so I call this u. Then here I plug g of x for u. And this is going to give me f of g of x plus c. So this tells me the following. I know that's a little bit hard, but it's going to get much easier very soon. So this tells me that this integral, I need to evaluate integral of the form f of g of x times g of prime of x dx. The only thing I really need is the antiderivative of f. So I can isolate this and compute it by itself. Once I do that, then once I evaluate this integral, we plug in g of x for u. Okay. That's really where the theory is coming from. Now, memorizing this is hard. I know it, and very hard. So keeping track with what's really going on here is actually hard. Keeping track with the idea that, okay, we have to use the chain rule to get here is a little bit hard. So there is a systematic way to use this formula, a systematic way that's going to help us memorize this formula. So here is how we're going to use it. So how to use this formula. How to use the formula above. So we don't have to memorize it the way it is. How to use the formula? We use it in the following way. Okay, we have this integral. That I want to compute, and we're going to introduce a variable called u. We're going to say, let's set u to be the inside function, or the function whose derivative is part of the integral. We're going to set u to be g of x. So my idea is that how we're going to memorize this concept without having really to go through what I just told you a minute ago. So we're going to set u to be this here. That's going to become f of u. And then we're going to compute du dx, the derivative. The du dx, we know what this is. This is g prime of x. That's the derivative. And then we multiply this. We're going to multiply this by dx. And we're going to get du equal g prime of x dx, that we call differential. Okay. Dx always, to help you mentally, dx is represent the delta x. So it's a quantity that represents the delta x, a little change in x. Once we do that, we're going to substitute everything inside the integral in terms of u, so I can get to this formula very easily. So now the important part, we substitute. We're going to substitute. That's really everything in x in terms of u. Everything in the integral in terms of u. in terms of u. Everything has to be in terms of u. Okay, let's do that. So what do I mean by that? Means the integral will become times g prime will become equal to everything in terms of u. Means g of x, this is going to become f of u. That's g of x. G prime of x dx. So this will become my du, and this will become my f of u. And this will be equal to integral of f of u du. Okay, so to memorize this formula, which is, we explain where it comes from, that's what we're going to do verbatim. So we're going to set u to be g, compute du dx, which is g prime, solve for du if you want, and then I get du is g prime of x. And then we're going to substitute everything in the integral in terms of u. And then I will get this is equal to f of u du. The last step is we evaluate now this integral. We're going to evaluate this integral as an integral in u. So now we have a new variable. And then we plug in at the end, we plug g of x for u. We will plug g of x for u. Okay. Now, it seems like a lot of stuff, but you will see it's not a lot of ideas. So the basic idea, we have integral where we have an inside, and the derivative of it is part of the integrand, and that's an important part. Okay. Well, if we have this type of integral, we set u to be the inside, the one whose derivative is right there staring at us. We compute the du dx, which is the derivative, gives me g prime, multiplied by dx will give me the du. We substitute everything in terms of u, I get this integral, which is really the one we want. We evaluate this. This should be easy to evaluate. Once we evaluate it, we plug in g of x for u. And immediately problems. So problem number 1 is the following. I'm going to take this integral, the simple one. Integral of 2x times the sine of x squared dx. Okay, and the question is evaluate this integral. All right. Does this integral have the form that I've been talking about? Do we have a function, which is basically the inside, whose derivative is part of the integrand? Yes or no? Do you really see in this the type of integral I've been talking about?
Yeah, x squared equals u and 2x dx is du.
Right, immediately. That's the type of integral. So we're going to put u to be x squared. That's how we're going to do it. Then du dx, if you want, if you ever forget what du is, you evaluate du dx, then you multiply by dx. Then will give me du is 2 dx. Now everything, that's crucial. Everything here, du is 2x dx. Everything has to be in terms of x. It means we're going to create a new integral that has nothing, there is no x in it. Everything has to be in terms of x. So it's going to be the integral of the sine of x squared. There is no problem with that. That's the sine of u. So this will become the sine of u. And 2x dx, this is my du. So now we have a new integral. That's a simple one. We evaluate this as an integral in u. As an integral in u, this is minus the cosine of u. Basically, I'm after the antiderivative of that function. That's the one I'm after. Okay, plus c. Once I evaluate it, the last step is we substitute x squared for u. And that's the end of the problem. Okay, so let us check immediately that we're doing it correctly. What does it mean to check? It means I take the derivative of my answer and make sure I get what's inside my integral. So we're gonna evaluate. It's equal to minus cosine x squared. Definitely the chain rule is the derivative of the outside, which is minus the sine evaluated at the inside times the derivative of the inside. Minus minus, it's a plus, which is going to give me 2x sine x squared. Check, we're right. Okay, all right. Problem number 2, again, another problem, which is also simple. Suppose I have the integral of 3x squared, let us say, divided by 1 plus x cubed to the power 3 dx, okay, or to the power 4. Okay. And the question is, do you see, again, do you see an inside function, and do you see its derivative part of the integral? You have to see those issues. Back to you. Do you see that? Do you see an inside? And the derivative of the inside is part of the integral.
Would it be u to the negative 4 du?
What's the u? The u.
The
u
u
is
is
part of
the
it.
u is 1 plus x cubed.
That's the important part. The u is going to be the heart. 1 plus x to the power 3. Because I see its derivative is part of the integral. So my du is going to be my derivative dx. And now everything in terms of u. So before I do that, I'm going to rewrite this in the following format. Dx. And now it's going to be equal to integral of everything. This will be my u to the minus 4. Now, this piece, 3x squared dx, usually I always told my student when I do those substitution, I keep an eye on the integrand and an eye here. So I have really to make sure I'm grasping everything. And this piece here, this is my du. So this is u to the minus 4 du. Once I have my integral on u, that's a new integral. That's the easy one I should be able to get to. That's the one I should be able to evaluate. Now this is going to give me 1 over minus 4 plus 1 u to the minus 4 plus 1 plus a constant c. It means minus a third u to the minus 3 plus c. So once I find this new integral in u, then I go back. The last step would be to substitute u in terms of x. That's the last step after I evaluate my integral. Plus c, or minus 1 over 3 times 1 plus x cubed to the power 3 plus c. Now we can check, and you should be able to check. It means check that when you differentiate your answer, that's what you have to check. You actually get 3x squared over 1 plus x cubed to the power 4. Make sure you check that so you know that you're getting it correct. Right. Now, again, we're going to do the same idea, but with a little bit of alteration. So I like to call those substitution with some alteration. With a little bit. Okay. Now let's say I'm going to take this integral of x times, let us say, 1 plus, times that. Okay. which is because we know very well that integral doesn't like square root. We have to rewrite it this way whenever we have the square root. All right, so now my question to you is, do you see an inside function and kind of its derivative outside, or kind of its derivative part of the integral? Yes or no? So do we see an inside? And almost its derivative outside, almost. This is MI inside in a way. So that's why I called with alteration, because u equal 1 plus x squared. Okay, the only issue here in this problem is that the du, remember, the du, it means you basically find the derivative and you multiply by dx. The du is 2x dx, okay? So the problem here is that this is my u, but the derivative of it is not quite outside, it's part of the integrand. Only the x part is part of the integrand. This is all right. We can handle those type of problem. So the way we're going to handle them is like this. We're going to actually, I only have the x dx. I don't have the 2x dx. So what we're going to do is we're going to divide here by a half. So we're going to divide by 2. Dividing by 2 will give me that a half du would be the x dx. So x dx is not the du, it's not. So the x dx is the half of du. So now what we're going to do, our substitution, that's what we're going to do. Everything in terms of u. So this piece will become u to the power a half. So as I said, I usually keep my eye on both things. And the leftover piece, this one, is not quite the du, it's actually half of du. That's what I meant with alteration. It means the derivative of the inside is not all of it part of the integrand, it's part of the integrand up to a constant. There is only one constant hanging in there, not more than that. And to be able to do it, we actually solve the way we did right here. So now this would become a half the du. So that's u to the half. The leftover is half the du. Now again, I have a simple integral in u, and this one I will do. A half is a constant. I can pull it out. Then I will have the antiderivative of this, which is equal to a half is a constant. This has to be a simple integral of the u. This has to be an easy one. 1 over a half plus 1 u to the half plus 1 plus c. So this will give me a half 2/3 u to the power 3/2 plus c. Now my final integral has to be a function of x, because my original integral is a function of x. This has to be a function of x. So at this stage, we substitute u by 1 plus x squared to the power 3/2 plus c. Okay, and then the rest is actually, that's the answer. And then we can differentiate to check that we're actually getting it correctly. So if I differentiate this piece, that's the checking part. Let's see, what do we get? 1/3 is a constant. The derivative of 1 plus x squared to the power 3/2, chain rule. It's the derivative of the outside, which is 3/2, 1 plus x squared to the 3/2 minus 1, times the derivative of the inside, which is 2x. So I will get the 3's canceled, the 2 canceled, I will end up with that, which is exactly what we started with. So, as I said, we will have to do a lot of problems along those lines. Okay, Now I'm gonna do this type of problem that I think my memory I did last time. I mean, not I did. I told you we have an issue with it. Okay. 1 over 5 plus 6x dx. Okay, and we want to do that by substitution. It's not as crystal clear as the other problems, but it's very close. So what I want me to take my u to be? Can do substitution, because this is, as I said, it's not the ln of 5 plus 6x. So I'm going to solve this problem by substitution. So how you think I'm going to pick my u to be? Even though you don't see quite, I don't know. What's your suggestion?
Why don't we rewrite it?
Yeah, I will write it. Very nice. No issue with that. I do everything you guys tell me. I will rewrite it. Okay, very nice. Now, do we have an inside function? Back to you. It means when I say inside, it means it's not x to the minus 1. Really? It's not x to the minus. It's like an inside. It's like a function to the minus 1, which is my function is 5 plus 6x. Because if I have x to the minus 1, I know what to do with it. I don't have that. I have a function to the minus 1. Now, do I have its derivative outside? Not quite. I don't have its derivative, but the derivative of that is just a constant. And constant doesn't give me a lot of problem. So if I compute this u dx, I get a 6. It means my du is 6 dx. So even though I don't have quite the derivative, I don't have the 6 here. I don't have its derivative here. But 6, a constant, doesn't really give me a lot of problem. What gives me a problem is a variable. So du is 6 dx. So I'm going to do the substitution now. And I said, I keep my I here and I keep my I a little bit here. So just to connect the dots. So let's do my substitution. This is u to the minus 1, no problem. But then I have the dx. What's the dx? I have to substitute in terms of du. But it's not a big deal. The dx is, if I divide by 6, it's going to give me 1 over 6 du equal to dx. So everything has to be in terms of u. So this is u to the negative 1. Fine, but then I still have the dx. But the dx, I can pull it very easily because it's just a constant in here. So times 1 over 6 du. Now I have a nice integral in u. I evaluate that. U to the minus 1. Now we know that this is the one that I should rewrite 1 over u du because n is minus 1. So this is 1 over 6, the ln of u. It means 1 over 6 ln of 5 plus 6x. Okay, so the 1 over 6 compensated for the chain rule that when we had difficulties, when you wrote ln of 5 plus 6x and you told me it's wrong, it's because the chain rule will have to multiply the derivative of ln of 1 plus 5x is 1 over 5 plus 6x times 6. But by dividing by 6, I actually eliminated the issue. And thus I compensated for the 6, which is coming from the chain rule. Right. Another problem. This one is going to be easy because, and then I will do one which is a little bit harder. So I'm going to do an easy one because I want you to see. Suppose I give you e to the cosine x. Okay, what do you see in here? Do you see an inside? Do you see its derivative part of the integrand? Do you see the scenario we're talking about? Yes or no? listening and reading and everything.
I don't see an inside.
Okay, anybody see an inside function? What do I mean by inside function? Let's talk about that a little bit. Suppose I tell you e to the cosine x, okay? Right, and let me take you back to the chain rule. And you're differentiating this. Forget about my problem for the split of a second. Actually, let me take another one. Let me take another one, and then I take you back to this. Suppose I take, so I'm gonna scratch this, totally scratch. Suppose I give you e to the x squared, okay? And I tell you, write this as the composition of two functions. What will be your inside? Back to you. For this one, what's gonna be the inside function? We did that at the beginning of the year. Let me see if you remember. What's the inside in this particular problem? If I give you e to the x, I mean, there is really no inside. What's the inside function here? The inside is x squared. That's really what my inside here. So my inside function here is x squared, and my outside is e to the x. That's really what we mean by inside, because that's the inside. And then if I take f of g with this scenario and I evaluate it, this is f of x squared, it means e of x squared. So this is becoming my inside function. All right, suppose I give you, again, 1 plus x squared to the power 4. And I told you, write it as g of f of g of x. What would be your inside? I'm just reviewing something we did at the beginning. And what's your outside? Your inside here is, or the inner function, inside or the inner will be the 1 plus x squared. The outer function or the outside function is x to the 4. I'm just reviewing the outer and inner. Now, if I have e to the cosine x, and I told you write it as f of g of x, what will be your inner or your inside? And that would be your outer function. Your inner here is the cosine. And your outer is e to the x. So that's what I mean by the inner function and the outer function, the inside and the outside. So if I take the integral that I took a minute ago, integral of sine x e to the cosine x dx. I wanted to analyze this. Do you see a function, which is kind of the inside, and the derivative of it, part of the integrand? Yes or no? Here, if I watch very carefully, I realize that I have a cosine x here, and its derivative to cosine is almost here, up to a sine. Almost here, there is a negative involved, but it's negative, we deal with it easily. So in this problem, to be able to solve this, we're gonna put u to be the cosine. That's what I mean, that's the inside, and that's where the derivative is there. And then I will find the du dx, which is minus the sine. Then I solve for my du, which is minus sine x dx. And now I evaluate everything. I substitute everything in terms of u. So this is gonna give me the following. E to the cosine will be e to the u. And this piece, the sine x dx, the sine x dx is right there. it's minus the du. So this would become minus integral of e to the u du, which is minus e to the u plus c, which is minus e to the cosine x plus c. End of the problem. So when I mean the inside, I want you to stare at the integrand and connect things. So how do we connect in this integral? The way we connect them is that I have here the cosine, and I almost have its derivative staring at me. So derivative of the cosine, which is part of the integrand. Whenever I have this scenario, I put my inside here to be my cosine. And what actually I'm doing is reversing the chain. Okay, I definitely have to stop right there. Please do your homework for tomorrow. Absolutely crucial that you do it. Do not postpone it this time. And we discuss this tomorrow. We'll do a lot of problems till you get this down very well. Okay, and as you guys know, the review for your final is on Blackboard. Please get started. You don't have a lot of time, unfortunately. So please get started. And if you have any questions, my office hours will start in 2 minutes, so please drop by. Any questions? Thank you, Elizabeth.
Have a good day.
You too. Bye-bye. I'll see you if you guys want. My office hours are starting, in 3 minutes.